Welcome back. Let's talk about writing your own classes. You just got schooled. Get it? Because you do classes in school? You get it? Ha! It's a joke from the 90s. So, in outline, we got to talk about some basic concepts encapsulation and state and behavior. These are the key concepts when we think about writing our own classes. We've got a couple of examples to work our way through the daily calorie counter and the water bottle, and then the implementation details, which we'll get to when we get there. Now, one note classes are the biggest conceptual shift that we're going to see in 141. It's a very different way of doing things, both conceptually and in terms of the implementation details, than everything we've done so far. You need to pay attention, you need to practice this stuff, you need to do some examples. Otherwise, it's going to be extremely difficult. Now, before you can worry about the implementation details, we're going to start with the concepts. Because if you don't understand the concepts, then it doesn't really matter what you're trying to implement. So in Java, classes are going to have both state and behavior. Broadly speaking, state is the data, behavior, that's going to be the methods. Now, the process of designing the state and behavior is called modeling. So let's talk about modeling things from life. What might be the state and behavior of a dog or a cat? I don't know. I mean, maybe the dog and the cat, maybe you want to know what their name is. Maybe you want to know the amount of food that they eat, how much they weigh, the color of their eyes, the softness of their fur. And how are we modeling these things? Well, they're going to be variables. They're going to be probably ints and strings and maybe a few other types of data that we're going to work with. Now, there's some questions to consider when we're doing state and behavior. We need to know if the behaviors affect the state, right? So, I mean, getting the name of a dog, that's a behavior, but it doesn't affect the state. Feeding the dog does affect the state of the dog. It makes the dog less hungry. If you feed the dog too much, it might make the dog fat. We got to take that stuff into account. Another key question, do two classes interact with each other? In other words, you might have a class called owner that models people that own dogs and cats, and you might have another class called dog that models a pet dog. Now, there may be a pet method that owners can invoke that actually is going to pet the dog and make the dog happy or make the dog, roll around and expose his tummy and things like that. So that's an interaction between two classes. That's another thing you need to think about is how all of your different classes interact. So let's try this out, modeling the world. Come up with one or two examples of things from the world that have state and behavior. It can be kind of whatever you want. This is a very abstract question. Don't worry about how you might implement this. You can discuss with other people. I've just put this up on Moodle. Go ahead and come up with, a couple of examples. You can even do this at the end of the video if you'd like. Some interesting examples we've come up with in years past. I had a student decided that he was going to come up with a Terminator robot class, and the state would be the name, the number of weapons, and the type of sunglasses. And the behavior that the Terminator has is to acquire sunglasses and to eliminate Sarah Connor. This is going back to the Terminator movies, with Arnold Schwarzenegger. So let's talk about encapsulation. Let's think about a string. What data do you think is actually encapsulated inside a string? In other words, how do you think a string is implemented? I'll give you a chance to try this out on Moodle. Did you come up with an array of characters? If so, that's probably right. That's almost certainly how a string is implemented, because we already know what characters are, we know what an array is. A string is really just some sort of list of characters, so it makes sense to implement a string as an array of characters. Now, a string is not just an array of characters, right? That is just the state, the data. Strings also have behavior or methods. So a string, we would say it encapsulates the characters. The string itself, of course, is bigger than just the characters. It also has methods that can manipulate its data and do various other things. So encapsulation, this concept, it lets us package together data to build something bigger. It's a very, very, very important concept in computer science. So here's a really, really simple thing we can model, a daily calorie counter. So what's the state that we're going to need for a daily calorie counter? In other words, what data is it tracking? And what are the behaviors? What operations or function is it going to have? And do they affect the state? Well, let's walk through this. The state, that's going to be the total number of calories. It's a daily calorie counter. We want to know how many calories you've eaten each day. And then what behavior are we going to have? Well, maybe we want to add a meal So given a number of calories, we're going to add those calories to the total number of calories that the calorie counter is tracking for that day. We also need a reset behavior, which will reset the calories to 0 to get ready for the next day. Now the state and behavior, these apply to a particular instance of calorie counter. You and I might have different calorie counters. In fact, I hope we will. So your daily calories are going to be different than mine. If I add a meal to my calorie counter, it should not affect your calorie counter. Otherwise, we have defective calorie counters, we need to return them. So the notion of an instance, this is actually very important because when you talk about a behavior or method, we need to know what instance, which encapsulates the state, it's going to apply to. Now before we write any code to build this new class, let's go ahead and demo how we can do this. So I'll start with the BlueJ workbench and then I'll work on a main method. So let's pop on over to BlueJ. Here's calorie counter. Now, if we right click on this, you notice we don't come up with a main. This doesn't have a main in it. Let's go ahead and use this. This is the constructor. We're going to go ahead and create a new one of these. Let's just pick the default name, Calorie1. That's fine. Shows up down here in the BlueJ workbench. Now, if I right click this, I can invoke the methods. Let's add calories. I don't know, 50 calories. Now if we double click and open this up, you can see this encapsulates an int, which actually stores the calories. We've got 50 in there. Let's reset it. Okay, that reset it down to 0. Let's add some calories. I just had 1,000 calories. And I had 500 more calories. We should have 1,500. We do. Let's reset it. Good. Now, that's one calorie counter. We can make another one with another constructor. We got to give it a new name, right? We can't name it Calorie1. We'll get an error message. Object already exists. We've got one down here. Let's create a new one. Bam. We're going to add 1,000 calories here. We're going to add, oops, here we go, 500 calories here. Open this one up, 500. Open this one up, 1,000. Right? It matters what method you're invoking matters what instance you're invoking a method on. Now we've also got calorie test. This is a standard main method that we've seen. Here it's directly invoking the constructor. We're printing out the calories are c.calories. This is that variable. We'll talk about how this works. It's an instance variable that the calorie counter encapsulates. So initially there should be 0, then we add 50, then 75, and so on. Let's run this and see what happens. So you can sort of see it's doing the predictable thing. 0, then 50, then 125, because if you look at what's happening, initially there's 0, then we add 50, we print it out, we add 75, we print it out, and so on. So that's what's going on with calorie counter. That's how we would use it. Now what we're going to do, we haven't opened this file up yet, we're going to look at how this is actually implemented. So here's the code. This is what it would look like to implement our very simple calorie counter. Now let's step through this. First of all, writing a class creates a new reference type. Now, we've been writing classes basically the whole term, and we haven't really been paying a lot of attention to this. We've kind of just thought of public class meaning, hey, I'm going to start a new program. This is the name of my program. Well, it turns out that that's actually a really limited way to do things. We've actually just been creating classes for the sole purpose of holding a main method, which is not actually a very good thing to do with classes. So what we're going to do instead is start thinking about creating a new class as a way of creating a new reference type. Now the name has to be a valid, legal Java identifier. By convention, it's going to start with a capital letter. Now we define our state. This is called an instance variable. Sometimes it's also called a field. Sometimes it's just called data. Instance variables are inside the class, but outside any method. You have to know this. You must know this. This will come up over and over and over again. And if you ask questions about it, I'm going to sort of like be pointing at this and saying, where is this method declared? Is it inside the class but outside any methods? That means it's an instance variable. You'll hear me say this over and over and over again. This is an instance variable. Now you notice it's not inside any method. It's not inside main. It's just sort of sitting here inside the class. That means it's state. This is the data that the calorie counter is going to store. It's an instance variable. That means it's available to all the instance methods. What are instance methods? We'll get there. Note that it looks like a regular variable declaration. We've got a type, we've got the variable name. Now we've got a constructor. We've used constructors before, we've never written a constructor. Constructor is a special method that creates a new instance. All constructors do is they set initial values for all the instance variables. That's not all they can do. You can actually do a huge amount of stuff in a constructor if you want. It's actually just a regular method, but it's generally not a good idea to do that. You want to restrict your constructors to just initializing instance variables unless you can think of a really good reason not to. If you're just sticking code in the constructor because you don't know where else to put it, you're probably doing it wrong. So you can see what we're doing here. We're initializing calories to 0. Now, some notes about the constructor. There's no return value, not even void. We've got public, then the name of the constructor. Now, the name of the constructor has to match the name of the class exactly. This is a requirement. And all we should do is set initial values. We'll come back to what the body of the constructor is doing later. These two things down here, these are instance methods. These can read or write instance variables. Now, how do we know they're instance methods? Well, for one, we're not using the term static. Static actually means the opposite of instance. So you see we've got a method here, we've got public, we don't have static, that means it's an instance method, then a return value, which in this case is void, then the name of the method, the parameters, and the body of the method. So it's really just a regular method, basically a function. But it's not static because we don't have the word static here, that makes it an instance method. Some notes about terminology. We've been calling things functions, but they're really static methods, right? When we have public static, we've been saying that's a function. Technically, it's not a function. Technically, it's a static method. But in reality, functions and static methods are the same. Doesn't really matter what you call them. You can call it a static method, you can call it a function, doesn't matter, as long as you understand that they are different than an instance method. This has no static in it, that means it's an instance method. Because it's an instance method, it has access to the instance variables, in this case, calories. Now, something to note here, these instance methods, when they're accessing the instance variables, they're sort of prefixing it with this. Saying this.calories lets us know I want the instance variable that is named calories. Otherwise, it's just like any other method. And so you can see what we're doing here. We've got a formal parameter, we've got a number of calories, and what we're doing is we're taking those calories and we're adding it in to the instance variable calories. Now, what this means is we're affecting the state. We're changing the state. This particular behavior, this particular method, it actually affects the state of our calorie counter. And you can see reset, this doesn't need any parameters because all it does is reset calories to 0. Okay, that was our first simple class for a calorie counter. Let's do another simple class, a water bottle. So what's the state, what's the behavior of a water bottle? Well, I don't know. Let's think about it. How about this? The state would be the current number of ounces of water in the water bottle and the maximum capacity of water in ounces. And the behavior would be adding water, and if we add more than the capacity, maybe it should let us know how much is left over. And then we can remove water, but if we try to remove more water than is in the bottle, ounces will just go down to 0, the current number of ounces, because you can't take more water out of the bottle than is in there. We're not going to have like negative water or like water deficits. So I'm going to demo this in BlueJ before we see any code once again. We're going to walk through 2 examples. We'll create a bottle with the maximum capacity of 10, and then we'll add 5, check the return value, and then add 8, and then we'll have a maximum capacity of 20 where we'll add 5 and remove 14. So let's try this out. So we've got water bottle, we open this up, we look at this, bam, that's what the code's going to look like. We'll get there in a second. Let's create a new water bottle. We're doing this first example. So we'll create a water bottle, the name of the instance, I'll call it WaterBot. Now the constructor needs a parameter, so I'll say create the first one with a capacity of 10. There we go. Let me move this over so we can, in fact, let me move all of this over so we can see our example. There we go. So we right click on this, we've got add and remove. Let's add a capacity of 5, and it comes back, the return value here is 0. Okay, that makes sense. I added 5, there's no extra. Fantastic. Now let's add 8. I added 8, there's 3 extra. Well, that makes sense. The capacity is 10. There's already 5 in there. If I add 8 more, that should fill it up, and I'm going to get back 3. Now, anything I add at this point, suppose I add 500, oops, I should come back with 500 because it's already at capacity. And then if I open this up and inspect it, we can see the current number of ounces is 10, and the capacity is actually 10. The water bottle is, in fact, full. Let's do another example. We'll make another water bottle. Water bottle 2, we'll put 20 ounces as the maximum capacity here. So let's inspect this. Capacity is 20, number of ounces is 0. What happens if we add 5? Basically what you'd expect. We get back 0, so there's no extra. We look in here, we've got 5. Fantastic. Now, if we try to remove 14, well, we don't get a return value. That's okay. But if we open it up, you'll see we reduce the ounces to 0. We weren't able to remove all 14. We only removed the 5 that were in there, and the other 9 we asked for, we just weren't able to get. So we're doing a little bit of work to make sure we don't go over the capacity or less than 0 for our current number of ounces. Cool. So that's the example. Here's the code. We sort of briefly glanced at this in BlueJ, but we're going to walk through this in significantly more detail. So try this out on the Moodle. What kind of variable is ounces? I'll give you a chance to try this out. Did you come up with instance variable? If so, you're right. Why is it an instance variable? It's inside the class, but it's outside any method. That makes it an instance variable. What kind of variable is max cap? I'll give you a chance to try this out. Did you come up with formal parameter? If so, you're correct. We know it's a formal parameter because it's the parameter inside a method declaration for the parameters. That is the very definition of a formal parameter. Now, this method happens to be a constructor, but that's okay. It doesn't really matter. It's still a method, even though it's a constructor. What kind of variable is capacity? I'll give you a chance. Did you come up with instance variable? I hope so, because it's an instance variable. How do we know? Inside the class, outside any method. Just like ounces. What kind of method is water bottle? I'll give you a chance to try that out. Did you come up with constructor? If so, you're correct. And I hope you came up with constructor because like 3 seconds ago, I said that it was a constructor. Now, how do we know it's a constructor? Well, other than the fact that I said it, it matches the class name exactly. It has no return type, not even void, and it's a method. So that makes it a constructor. If it has exactly the same name as the name of the class and it doesn't have a return type, that means it's a constructor. I should mention that local method and reference method, those are not real things. In fact, there's only instance methods, static methods, or functions, and constructors. There aren't other kinds of methods in Java. There's only those 3. What kind of method is add? Did you come up with instance method? If so, you're right. How do we know it's an instance method? Well, it's not a constructor. It doesn't have the word static in it. Local method is still not a thing, because it wasn't a thing a second ago, so it didn't suddenly become a thing. So, therefore, it's got to be an instance method. And what kind of method is remove? Also an instance method. Same reason as for add. It's not a constructor. The word static's not there. It's an instance method. And we can tell it's trying to be an instance method because it's accessing instance variables. Right? So clearly this means to be an instance method. What kind of variable is extra? I will give you a chance to try this out. Did you come up with a local variable? If so, you're correct. Now, how do we know it's a local variable? Well, it's created inside a method. Therefore, it's local to that method. In fact, not only it's in the add method. In fact, not only is it in the add method, it's actually in these brackets. So its domain, it lives only inside these brackets. That's its medieval fiefdom lord there. And this variable is not going to be able to get out of there. So it can't outlive the method. It's local to the method. And that's actually all we've got. I should also mention there aren't really other kinds of variables. There's local variables, there's parameters, there's instance variables. There's actually a thing called static variables, but we're not going to use them in CS 141. They're useful in certain instances, but we're not going to really mess around with those. That's actually all we've got for this particular example. Now we're going to do a lot more with classes. Remember, keep in mind, with classes, there's the mechanics, the details of getting all of this new syntax right, understanding instance variables, instance methods, using this in the appropriate place, so on and so forth, writing constructors. You've got to get those mechanical details down. But don't lose sight of the big picture. Why are we writing classes? What problem are we modeling? What are we trying to solve? What are we trying to do with these classes? Try not to get bogged down in the details if at all possible. Thanks for listening. Talk to you again soon.